Hello everyone. So in this video I am going to discuss about computer network MCQ questions. So these questions will be helpful for the GATE, CSE and even UGC net examinations. So in the previous video I already covered a few questions. So in continuation with that we'll discuss in this video the default subnet mask for the class B network can be. Okay, so you know the range, the class B, okay, 128 to 191, 128 to 191, that is the class B range. For class A, that is 127, okay, 120 means that is 1 to 126. So 127 dot something, that is reserved for the loopback IP address. So here the question is the default subnet mask for class B network can be. Okay, class B network can be. So here you can see the solution, the answer for this. The class A, that addresses, that includes IP address that range from 1 to 126 only, that is a class A address 1 to 126, and IP address 127.xxx, it is reserved for the loopback IP address. Then class B IP address that ranges from 128 to 191, okay, 191.255.xx, okay, means any value 8-bit. So the default subnet mask for class B is 255.255.xx, means this option will come for class B, 255.255 any value, means here this is the only option that is for class B. Then class C IP address that ranges from 192 to 223, 192 to 223. So the default subnet mask for class C is 255.255.255.x, that is for the class C. Okay, so the next question, if there are n devices nodes in the network, what is the number of cable links required to look at for a fully connected mesh and the star topology respectively? For the mesh and star topology, if there are n devices, okay, so for fully connected mesh we can also be called as a complete graph. Okay, fully connected means we can call it as a complete graph. So it has total number of cable links with n nodes, okay, with n nodes, number of nodes in a network with n nodes, that is n into n minus 1 by 2, n into n minus 1 by 2. So in star topology the total number of cable links are n minus 1 in star, okay, in star topology. And in mesh fully connected mesh where n number of nodes, that is n into n minus 1 by 2, n into n minus 1 by 2. So the correct answer is here, this one. Okay, so this green indicates that is the correct answer. N into n minus 1 by 2 for the mesh network, and for the star topology n minus 1 for n number of nodes in a network. Then which of the following protocol is used for transferring the electronic mail message from one machine to another machine? So for mail message means, so that is a simple mail transfer protocol, SMTP. Okay. And what about the telnet? Telnet is for the telephone network. Telnet for the telephone network, and FTP, that is a file transfer protocol. That is a file transfer protocol. File transfer protocol. And SNMP is a simple network management protocol. Simple network management protocol. SNMP. Simple network management protocol. And SMTP is the simple mail transfer protocol. SMTP is the correct answer. Simple mail transfer protocol is an intermediate internet standard for email transmission. So mail servers and other mail transfer agent, they use SMTP to send and receive the mail on which port? That is a TCP port 25. TCP, this is also one time they asked this question. TCP port 25. TCP port 25. Which media access control protocol is used by the IEEE 802.11 wireless local area network? Okay, media access control protocol used by the IEEE 802.11 wireless. So for 802.11 wireless LAN, wireless local area network, that is a CSMA, carrier sense, okay, multiple access. So this layer that provides the same function as the MAC layer in the wired local area network, that is a IEEE 802.11 instead of using the Ethernet. So this scheme is called as CSMA CA. CA stands for collision avoidance, the packet collision avoidance. In wireless environment, since a station may not be able to hear all other stations, collision detection is not feasible. So the media access control protocol, that is CSMA CA. CSMA CA, that is issued by the is used in the 802.11 wireless local area network. Okay, CSMA CA. An Ethernet frame that is less than the 802.3 minimum length of 64 octet is called Ethernet frame. Ethernet frame that is less than the 802.3 minimum length of 64 octets is called as a runty frame. Runty frame, that is the Ethernet frame less than the IEEE 802.3 minimum length of the 64 octet, that is a runty frame. Then match of the following suitable questions. Okay, match of the following. Here you can see there is a list 1 and list 2 is there. I think it is not visible, so I will just read out this. The multicast group membership. Multicast group membership. Okay. Then interior gateway protocol. So multicast group membership. So that is supported by the IGMP. Multicast group membership. Then interior gateway protocol, exterior gateway protocol, then RIP. RIP. So just discuss what are these things. Internet group management protocol, that is IGMP. Internet group management protocol, IGMP, is a communication protocol used by the host and adjacent routers on IPv4 network to establish the multicast group membership. So IGMP, Internet Group Management Protocol, it is an integral part of the IP multicast. IGMP, it is an integral part of the multicast group membership. Multicast group membership. Okay. IGMP, multicast group membership, Internet Group Multi Management Protocol. IGMP is used along with the IPv4 network to establish the multicast group membership. Then OSPF, Open Shortest Path First. OSPF, Open Shortest Path First, is a routing protocol for IP network which uses a link state routing algorithm and falls into the group of interior gateway protocol. IGP, interior gateway protocol. Okay, so that is 2. OSPF, open shortest path first. Okay, so it is a routing protocol that uses link state routing algorithm that falls under the interior gateway protocol, IGP. Then border gateway protocol. Border gateway protocol, it is a standardized exterior gateway protocol. Open shortest path first, that is interior gateway protocol. Border gateway protocol, BGP, it is a standardized for the exterior gateway protocol designed to exchange the routing and reachability among autonomous system in the internet. Then RIP, routing information protocol. RIP, routing information protocol. Routing information protocol. Routing information protocol is one of the oldest distance vector routing protocol which employs hop count as a routing metric. Routing information protocol, RIP, routing information protocol. So it is one of the oldest distance vector routing protocol. Okay, here you can see the routing information protocol, that is a distance vector routing. Okay, then exterior gateway protocol, that is a border gateway protocol. C is 4th. Okay, so next question, MD5. MD5 is widely used hash function for producing hash value. So MD5 is widely used hash function for producing the hash value of 128 bits. 128 bits. So message digest algorithm, MD5 means There is a MD5 message digest algorithm. Message digest algorithm that is widely used hash function to produce the 128-bit hash value. 128 bits hash value, MD5 message digest 5 algorithm. So it is mainly designed for cryptographic hash function, and it has been found to suffer from extensive vulnerabilities, means attacks. So MD5, that is a 128-bit function hash value, 128 bits. Which protocol suite designed by IETF to provide the security for a packet at the internet layer? Which protocol suite that is designed for IETF, Internet Engineering Task Force, Internet Engineering Task Force, okay, IETF, IP Security Working Group, okay. So that is open, freely available set of security extension called IP security, okay. IP security protocol suite that is designed by the Internet Engineering Task Force to provide the security for a packet at internet layer, security for the packet at the internet layer, okay. IP security, IP security. Then pretty good privacy, it is used in PGP, pretty good privacy. It is mainly used in the email security, email security. PGP, pretty good privacy encryption program that provides a cryptographic privacy and authentication for the data communication, that is for the mail or not emails, okay. So whichever the mail we use for our personal mail or any business communication, for this mail communication, PGP, it is used for signing, encryption, decryption of the text, okay. Then files, directories, all disk partitions, okay. So that security of the email communication, that is done by the this PGP, pretty good privacy encryption program. So it is developed in 1991. It also uses digital signatures to provide the authentication and integrity checking, basically to check the message is actually sent by the person. Then what is the WPA? WPA, Wi-Fi protected access, Wi-Fi protected access, Wi-Fi protected access, WPA, Wi-Fi protected access. WPA, that stands for Wi-Fi protected access, it is a security standard for computing the devices that equipped with wireless internet connection. Wi-Fi protected access, it is a security standard. Wi-Fi WPA, protected access security standard, that is for the computing devices equipped with wireless internet connection. So SATA is the abbreviation of Serial Advanced Technology Attachment. Serial Advanced Technology Attachment. Okay, it is standard for connecting and transferring the data from hard disk drive to computer system. Okay, Serial Advanced Technology Attachment. Serial Advanced Technology Attachment. Then a public key encryption system. A public key encryption system. Public key means it allows the correct receiver to decode the data. Public key encryption system. Private key, public key. So public key encryption system. So what it does, it allows the correct receiver to decode the data. Correct receiver. Okay, so public key encryption is a cryptographic system that uses two keys. A public key is known to everyone, and a private key or secret key that is known to the recipient of the message, the who is going to receive the message. Okay, public key means that is known to everyone. Private key or secret key is known only to the recipient of the message. So a receiver can decode the message using his own private key and the public key of the sender. Okay, so public key of the sender. So a receiver can decode. Okay, with the public key of the sender, public key of sender and private key of the recipient, so he can decode the message. In networking, UTP stands for unshielded twisted pair. Unshielded twisted pair. UTP stands for unshielded twisted pair. Is ubiquitous type of copper cabling that is used in telephone wiring and local area networks. Ubiquitous type of copper cabling that used in telephone wiring or local area network, that is UTP. Okay, unshielded twisted pair. The address resolution protocol, ARP, address resolution protocol, is a communication protocol used for discovering the link layer address, such as MAC address associated with a given internet layer address. Okay, finding the MAC address that corresponds to an IP address. Address resolution protocol, ARP, that is used to find the MAC address that corresponds to an IP address. Corresponds to an IP address. Okay, address resolution protocol, ARP protocol, that finds the MAC address that corresponds to the IP address. Which of the following is a MAC address? Okay, which of the following is a MAC address? So MAC, medium access control address, is a device, a unique identifier assigned to a network interface controller. A unique identifier that is assigned to the NIC, network interface controller. Okay, MAC address, it is a unique. So MAC address are recognized as a six group of two hexadecimal digits. Okay, so six groups of two hexadecimal digits. Hexadecimal means that is two hexadecimal means it is 8-bit. Okay, so there are six group of two hexadecimal digit that is separated by the hyphen. okay, or colon, or no separator. Okay, so this is IP address. A is IP address, so B is not, C are not the example, so here it is MAC address. Okay, there are six 1 2 3 4 5 6 6 groups are there with the two hexadecimal digits, two hexadecimal digits. Okay, two hexadecimal. Then what is the primary purpose of virtual local area network? Virtual local area network is a logical group of workstations, logical a group of workstation server network devices that appear to be on the same local area network despite of their geographical distribution. So virtual local area network, so it allows a network of computers and users to communicate in a simulated environment as if they exist in a single local area network and are sharing a single broadcast and multicast domain. So the primary purpose of the virtual local area network is segmenting a network inside the switch or a device. Okay, segmenting a network inside a switch or device. That is the main purpose of virtual area network. VLAN, virtual local area network. Higher end switches allow the functionality and implementation of VLANs. VLAN address issues such as scalability. It addresses these issues: scalability, security, network management, network architect setup. Okay, to provide the network segmentation, and also addresses the security issues. Virtual local area network. So what is SHA1? Okay, so these are all questions that are asked in the ISRO. Secure SHA1. Okay, so this is a message digest function. SHA1 is a message digest function. So it produces the 160 bit of hash value. Okay, it produces the 160 bit of hash value or message digest from a inputted data. Okay, so SHA1 is a message digest function, MD5 algorithm. Advanced encryption standard, AES, it is based upon a symmetric key algorithm. AES is based upon the symmetric key algorithm. AES, advanced encryption standard. AES, advanced encryption standard, it is based upon the symmetric key algorithm. Okay, AES is a asymmetric block cipher that is chosen by the US government to protect the classified information. So AES is a symmetric key algorithm. So what is bit stuffing? Bit stuff, that is, bit stuffing means adding. Bit stuffing, it refers to the inserting a zero in a user stream to differentiate it with a flag. Inserting a zero in a user stream. Bit stuffing is most easily described as insertion of a 0 bit, okay, after a long run of 1 bits. Bit stuffing. Bit stuffing is insertion of a 0 in a user stream to differentiate it with a flag. So SDLC is transmitted a bit sequence of this one containing a 6 adjacent 1 in a flag bit. So bit stuffing ensures this pattern can never occur in a normal data. So it inserts a 0. It inserts a 0 to differentiate it with a flag. Dynamic routing protocol that enables routers to dynamically discover and maintain the route. It reaches the agreement with other routes about the network topology and distribute the routing updates to the other routers. Distribute routing updates to the other routers. So that is all of the above. The answer is all of the above. Dynamic routing protocol. In Ethernet, CSMA CD is the special bit sequence that transmitted by the media access management to handle the collision jam signal. It sends a jam signal. CSMA CD, once the collision is detected, the colliding devices send a jam signal. It sends a jam signal. So assuming you know the collision detection method that is used, CSMA CD, the jam signals are generated after the collision. Okay, jam signals when after the collision, and it informs the devices that collision has occurred and invokes a random backup algorithm which forces the devices on the Ethernet not to send any data until their timer expires. So in Ethernet CSMA CD, the special bit sequence transmitted by media access manager to handle the collision is called as jam signal. Which network protocol allows the host to dynamically get a unique IP number on each boot up? Dynamic Host Configuration Protocol, DHCP protocol allows the host in a network that dynamically gets a unique IP number to each boot up. A router or the residential gateway that can be enabled to act as a dynamic host configuration protocol server, DHCP. Most residential network routers they receive the globally unique IP address within a ISP network. So within local network, DHCP server assigns locally the IP address to each device connected to the network. Okay, so DHCP that assigns the local IP address to each device that is connected to the network. In a token ring network, the transmission speed is 107 bits per second and that propagation speed is 200 meters per microsecond propagation. The 1 bit delay in this network is equivalent to. So here you can see the total. There is a 1 bit delay is there, and here it is actually 10 raised to 7. 10 raised to 7, that is. 10 raised to 7 bits per second. So the total time 1 divided by 10 raised to 7, so that is 0.1 microsecond. Okay, that is 0.1 micro. TP is 200, the propagation time. So therefore 200 microsecond, 200 into 0.1, that is 20 meter. The address of class P host to be split into subnets with 6-bit subnet number. What is the maximum number of subnets and the maximum number of hosts in each subnet? Class P host is split into subnets with 6 subnet numbers. What is the maximum number of subnets and the maximum number of hosts in each subnet? So in class B there are 16 bits for the network ID and 16 bit for the host ID in class P. 16 bit for the network ID and 16 bits for the host ID. So from host ID we will look 6 bits for the subnetting. Then the total subnets possible is 2 raised to 6 minus 2, that is 62. Then okay, so 16 bit for network ID, 16 bits for the host ID, and from the host ID we'll take 6 bits for subnetting. Then total subnets 62. So total hosts possible for each subnet is 2 raised to total 6 we are used for, so remaining is 10. So 2 raised to 10 minus 2. 6 is for the subnet. Okay, total subnet possible 2 raised to 6 minus 2. And for the host the remaining is 10. So 2 raised to 10 minus 2, 1022. So 62 subnets and 1022 host. The message 11001001 that to be transmitted using the CRC polynomial x cube plus 1 to protect it from the errors. The message that should be transmitted as, okay, so the CRC polynomial is x cube plus 1. So in data there are x cube plus 1, there are 3 zeros need to be append to the data. So here this is the data 111001001. So here x cube plus 1 is there, so there are 3 zeros append to the original the data. Okay, then so this will come, okay, original. Here the three bits are appended here, 3 zeros are appended. Okay, so x cube plus 1, so it is divided by 1001. So that is 9, and if you do the division, and here XOR operation is there. So once we do the division, the data transmitted will get what is the maximum size of the data that application layer can pass on the TCP layer below. The maximum size of the data that application layer can pass on the TCP layer. Application layer can pass on the TCP layer below. So application layer any size, okay. And for transport layer 65,515 bytes, and network layer 65,535 byte, the data link layer 1500 byte. So that is the maximum size. Next question, a frames of 1000 bits are sent over 10 raised to 60 10 raised to 6 bits per second duplex link between the two hosts. The propagation time is 25 millisecond. The frames are to be transmitted into this link to maximally pack them in transmit. What is the minimum number of bits that will be required to represent the sequence numbers distinctly, assuming that no time gap needs to be given between the transmission of two frames? So here the frames are 1000 bits. 1000 bits are sent over 10 raised to 6 bits per second duplex links between the two hosts. So 1000 bits over 10 raised to 6 bits per second. Okay, that is 1 millisecond. The maximum number of frames that can be transmitted to maximally pack them is TT, the travel time, propagation time divided by T, Tx. So the travel time, the propagation time is 25 millisecond that transmitted into the link to maximally pack them in transmit. 25 plus 1, 26 is the window size. Minimum sequence number required is 26. Minimum number of bits required in sequence number is 5. When DNS server accepts and uses the incorrect information from host that has no authority giving that information, the DNS server is accepts and uses the incorrect information from a host that has no authority giving that information, then it is called as spoofing. It is called as data spoofing. That is a DNS spoofing. Okay, as a DNS cache poisoning is a form of computer security hacking in which corrupt domain name system data is introduced into the DNS resolves cache, causing the name server to return an incorrect result record. IP security is a tunnel mode result in IP packet with new header. IP packet with new header. IP security can be used in create the virtual packet VPN tunnels to end-to-end IP traffic. IP packet with new header. IP security can be used to create the VPN tunnels to end-to-end IP traffic, end-to-end IP security transfer mode, or site-to-site IP security tunnels between the two VPN gateway. So use of this IP security in tunnel mode results in IP packet with new header. IP packet with new header. New header. The subnet mask for particular network. Subnet mask for particular network is 255.255.31.0. This is the one of the network. So we need to find the subnet mask. Which of the following pairs of IP address could belong to this network? So the subnet mask for this network is that we can find out to find that whether host belong to the same network or not. So we have to find their network ID. The network ID is the same, then host belong to the same network. So that we can find by ANDing. ANDing an IP address. So 120. So here we can perform the AND operation. 128.8.129.43 bitwise AND with this one. Perform the ANDing operation. Okay, we'll get this one 128.8.1.0. Okay, so that indicates it is belong to that particular network. Okay, so here you can do the ANDing operation 255. Okay, like 128, you can do the binary and do the AND operation. Okay, then we can find the subnet mask for a particular network. The encoding technique used to transmit the signal in Giga Ethernet technology over the fiber optic medium is 8B by 10B in a line code that maps 8-bit words, 8-bit of words to 10-bit symbols. 8-bit of words to 10 symbols. 10 symbols. Okay, 8B by 10B encoding. What is the raw throughput of USB 2.0 technology? A raw throughput USB 2.0 technology is 480 megabits per second. Okay, for USB 2.0 is 480, and USB 3.0 super speed path. Okay, so that operates a bit rate of 5 gigabits per second. Okay, USB 3 at 5 gigabits per second, and USB 2.0, that is 480 megabits per second. The network protocol which is used to get the MAC address of a node that is provided by the IP address. Network protocol that is used to get the MAC address, that is ARP, address resolution protocol. Address resolution protocol that is used to find the MAC address. MAC, unique address of a device, MAC address, okay, of a device using the IP address. So RARP, reverse address resolution protocol, is the vice versa of ARP, and it is in which the physical machine, in which local area network can request to learn its IP address from the gateway server. An example of polyalphabetic substitution is Vigenère cipher. Polyalphabetic cipher is any cipher based on the substitution using multiple substitution alphabets. So Vigenère, Vigenère, Vigenère cipher. Vigenère cipher, okay, is the best example of Vigenère cipher is the best example of polyalphabetic cipher. IEEE standard for WiMAX, wireless worldwide interoperability for microwave access. WiMAX, worldwide interoperability for microwave access, that is IEEE 802.16, 802.802.16, okay, for WiMAX, worldwide interoperability for microwave access, interoperability for the microwave access. In which layer of network architecture the secured socket layer is used? SSL, secured socket layer, is used in presentation layer. Secured socket layer is a networking protocol used at transport layer to provide the secure connection between the client and server over the internet. It places itself as an application layer protocol in the TCP IP reference model and as presentation layer in the OSI model. Okay, so presentation layer in the OSI model, secure socket, and in TCP IP reference model, okay, that is in the transport layer. But in presentation layer of OSI model, that is a secure socket layer is used. The broadcast address of IP network 172.16.0.0 with subnet mask is broadcast address of the IP. So this broadcast address of IP network with subnet mask is that we can calculate. So convert, this is IP network, then subnet mask. So convert the above two addresses into binary format. Okay, 170.16.0.0 and subnet mask, convert into binary, okay, and perform the bitwise AND operation. Bitwise and operation. Okay, so which is nothing but a broadcast address. All bits of the subnet address is set to ones. Okay, so the address is here we will get 172.160.0.0. Okay, so the broadcast address means all the bits of the subnet address is set to 1. Okay, all the bits of subnet address, this is set to 1. So that is 172 here, 172.16, right? It is not 160, it is 16. So this and this, it is set to 1. Okay, set to 1. So that is the address. Okay, so this is all about up to 70 questions, and in the next video we'll continue with that, and we'll discuss almost we're at the target of 1000 questions.